In the darkest days of World War II, German U-boats were winning the Battle of the Atlantic. Thousands of Allied ships were being sent to the bottom of the ocean every month. Britain was being starved into submission by submarine warfare. Then one revolutionary weapon changed everything. The Hedgehog anti-submarine mortar turned the tide of the most crucial battle of the war. This is the story of the weapon that saved the Allied convoys and helped win World War II. When war erupted in September 1939, the British Royal Navy faced an immediate crisis. Germany's submarine fleet, the U-boat force, began attacking merchant shipping with devastating effect. These submarines hunted in wolf packs, coordinating attacks on Allied convoys. The losses were catastrophic, threatening Britain's ability to continue fighting. In 1940 alone, over 1,000 Allied ships were sunk by submarines. Britain depended entirely on imports for survival, food, fuel, and war materials. If the shipping lanes were cut, Britain would be forced to surrender within months. Then the Battle of the Atlantic became the longest continuous military campaign of the entire war. From the first day of the war to the last, submarines and escort ships fought for control of the sea lanes. Winston Churchill later wrote that the U-boat threat was the only thing that truly frightened him during the war. The existing anti-submarine weapons were proving inadequate against modern submarines. Depth charges had been the primary anti-submarine weapon since World War I. These were essentially large barrels filled with explosives that were rolled off the back of escort ships. They would sink to a preset depth and then detonate, hopefully damaging the submarine. But depth charges had serious tactical limitations that U-boat commanders learned to exploit. The most critical problem was that escort ships had to pass directly over the submarine's position. To attack with depth charges, the escort had to sail over where the submarine was detected. This meant losing sonar contact at the most crucial moment of the attack. Sonar, called ASDIC by the British, could only work when pointed forward. As the escort ship passed over the submarine, the sonar could no longer track the target. The submarine had precious seconds to maneuver, while the escort ship was blind. Experienced U-boat commanders would execute emergency turns or depth changes during this blind period. By the time the depth charges exploded, the submarine had moved away from the attack point. The depth charges would detonate in empty water while the submarine escaped. Another problem was the delay between losing contact and the depth charges exploding. Depth charges took time to sink to the preset depth before detonating. This could be 30 seconds or more depending on the depth setting. During this time, a submarine could travel hundreds of feet away from where it was last detected. The escort ship had to guess where the submarine would be when the charges exploded. This guesswork rarely resulted in direct hits on the submarine. Depth charges also had a relatively small lethal radius. A submarine had to be within about 20 feet of a depth charge explosion to be destroyed. Damage could occur at greater distances, but many submarines survived even close calls. U-boats were built with strong pressure hulls that could withstand considerable shock. Unless a depth charge exploded very close, the submarine could usually survive. The typical depth charge attack involved dropping dozens or even hundreds of charges. Escort ships would make repeated runs over the suspected submarine position. Each run dropped a pattern of depth charges, hoping to saturate the area. This was enormously wasteful of resources and time. Escort ships carried limited numbers of depth charges, perhaps 40 or 50. A single extended engagement could exhaust the escort's entire supply. Then the escort would have to return to port to rearm, leaving the convoy vulnerable. The success rate of depth charge attacks was disappointingly low. Statistics showed that hundreds of depth charges were expended for every submarine actually destroyed. In the early war years, the odds heavily favored the submarines. U-boat commanders knew the limitations of depth charges and developed effective counter-tactics. They would dive deep, make radical maneuvers, and wait for the escort to exhaust its weapons. Many submarines survived multiple depth charge attacks and continued hunting. British naval officers recognized that a new approach was desperately needed. The Admiralty's Department of Miscellaneous Weapons Development was tasked with finding solutions. This department, sometimes called the Wheezers and Dodgers, specialized in unconventional weapons. The challenge was clear: create a weapon that could attack submarines while maintaining sonar contact. The weapon needed to strike ahead of the escort ship, not behind it. This would allow the ship to track the submarine right up to the moment of attack. Several concepts were explored before the breakthrough came. The solution was inspired by an unlikely source, a simple garden tool. The weapon would be named Hedgehog because its array of projectiles resembled the spines of a hedgehog. But the path from concept to operational weapon was filled with technical challenges. The basic idea was revolutionary: mount mortars that fired forward from the ship. These mortars would launch multiple projectiles in a pattern ahead of the vessel. The projectiles would sink and detonate only on contact with the submarine. This contact detonation was crucial and represented a major innovation. Unlike depth charges that exploded at a preset depth, Hedgehog projectiles were inert until they hit something solid. If they missed the submarine, they would simply sink to the bottom without exploding. This meant the sonar operator could immediately tell if the attack was successful. An explosion meant a hit, no explosion meant a miss. With depth charges, huge explosions occurred whether they hit anything or not. The explosions disrupted sonar and created confusion about whether the submarine was hit. Hedgehog eliminated this confusion with its simple feedback mechanism. The development of Hedgehog began in earnest in 1941. The design team was led by officers and engineers from the Royal Navy's research departments. They faced numerous technical obstacles that had to be overcome. The mortar system had to be compact enough to fit on small escort vessels. Corvettes and destroyers had limited deck space, so the weapon couldn't be too large. The projectiles needed sufficient explosive power to destroy a submarine on contact, but they also had to be small enough to fire multiple projectiles in a single salvo. The contact fuse mechanism had to be reliable and safe. It couldn't detonate prematurely from the shock of being fired or hitting the water, but it had to detonate reliably when striking a submarine's hull. The mortar launchers had to fire all projectiles simultaneously in a precise pattern. If the timing was off, the projectiles would land in a useless random scatter. The aiming system had to work with the ship's existing sonar equipment. After months of testing and refinement, the final design emerged. The Hedgehog launcher consisted of 24 Spigot mortars, arranged in 4 rows. Each mortar was a simple steel rod with a firing charge at the base. The projectile slid down over the spigot and was launched when the charge fired. This Spigot mortar design was simple, reliable, and inexpensive to manufacture. The projectiles themselves were approximately 30 pounds each. They were shaped like small bombs with a contact fuse in the nose. Each projectile contained about 35 pounds of Torpex explosive. Torpex was 50% more powerful than TNT, making these small projectiles devastatingly effective. The entire launcher was mounted on a tilting frame that could be aimed. The mortar bank was angled forward at about 45 degrees. This angle determined the range and trajectory of the projectiles. When fired, all 24 projectiles launched within a fraction of a second. They arced through the air and splashed down in an elliptical pattern ahead of the ship. The pattern covered an area approximately 100 feet long and 40 feet wide. This created a deadly field that was difficult for a submarine to avoid. The range of Hedgehog was approximately 200 yards ahead of the firing ship. This forward throw was the key innovation that solved the contact loss problem. The escort ship could maintain sonar contact right up until the projectiles hit the water. The aiming procedure integrated seamlessly with existing sonar operations. The sonar operator would track the submarine and provide bearing information. The ship would be steered to put the submarine directly ahead. When the range closed to the optimal firing distance, the Hedgehog would be fired. The projectiles would land right where the sonar showed the submarine to be. This direct approach eliminated the guesswork inherent in depth charge attacks. The first Hedgehog installation was fitted to HMS Westcott in January 1942. Initial trials revealed some issues that needed refinement. The recoil from firing all 24 mortars simultaneously was considerable. Mounting systems had to be reinforced to handle the shock. The contact fuses proved sensitive and occasionally failed to detonate. This was improved through design modifications and better manufacturing quality control. Crews needed training on the new weapon and its tactical employment. The attack technique was different from depth charging and required practice. Despite these teething problems, Hedgehog showed immediate promise. The first kill using Hedgehog came in November 1942. HMS Vanish successfully attacked and destroyed U-boat U-581 using Hedgehog. This confirmed that the weapon worked exactly as designed. The submarine was hit by multiple projectiles and sank immediately. There was no doubt about the result. Explosions meant confirmed kills. Word of this success spread rapidly through the escort forces. Captains began requesting Hedgehog installations for their ships. Production ramped up to meet the demand from escort squadrons. By mid-1943, Hedgehog was being fitted to hundreds of escort vessels. British, American, and Canadian escort ships all received Hedgehog systems. The weapon became standard equipment for anti-submarine warfare across the Allied navies. The tactical advantages of Hedgehog quickly became apparent in combat. Escorts could prosecute attacks faster and more efficiently than with depth charges. The ability to maintain sonar contact during the attack was revolutionary. Operators could make last-second corrections based on submarine movements. This dramatically increased the probability of hitting the target. The contact-only detonation provided immediate feedback on attack results. If there was no explosion, the crew knew immediately they had missed. They could quickly reload and make another attack without wasting time. With depth charges, crews often spent hours uncertain whether the submarine was hit. Hedgehog eliminated this uncertainty and allowed rapid follow-up attacks. The quiet approach of Hedgehog attacks had another unexpected benefit. When projectiles missed and didn't explode, the submarine crew might not even know they were under attack. Depth charges exploded whether they hit or not, alerting the submarine to the attack. The submarine commander would then take evasive action and go deeper. With Hedgehog, a miss produced no explosion and no warning to the submarine. The escort could reload and attack again before the submarine realized anything was happening. This psychological advantage favored the escort ships significantly. The statistics on Hedgehog effectiveness told a compelling story. With conventional depth charges, the kill rate was approximately 5% per attack. This meant 19 out of 20 depth charge attacks failed to sink the submarine. With Hedgehog, the kill rate jumped to over 20% per attack. This was a fourfold improvement in lethality. 1 in 5 Hedgehog attacks resulted in a confirmed submarine kill. This dramatic improvement fundamentally changed the dynamics of anti-submarine warfare. U-boat commanders who had previously felt relatively safe from escorts now faced lethal danger. The improved kill rate meant submarines couldn't survive multiple attack runs. Eventually, a Hedgehog-equipped escort would score a hit and end the engagement. The weapon also proved more economical in terms of ammunition expenditure. A single Hedgehog attack used 24 projectiles totaling about 720 pounds of explosives. A typical depth charge attack used dozens of charges totaling several tons of explosives. Hedgehog delivered better results with less than 1/4 the explosive weight. This meant escort ships could carry more attacks worth of ammunition. A ship with Hedgehog could engage multiple submarines without running out of weapons. The compact projectiles took up much less storage space than depth charges. Reloading Hedgehog was also faster than reloading depth charge racks. The crew could prepare for another attack in just a few minutes. This rapid reload capability allowed persistent attacks on submarines. Combat reports from 1943 showed Hedgehog's growing impact. U-boat sinkings increased dramatically as more escorts received the weapon. German submarine commanders began reporting encounters with a new forward-firing weapon. They described projectiles falling around them with deadly accuracy. The psychological impact on U-boat crews was significant. Previously, depth charge attacks were survivable through skilled maneuvering. Hedgehog attacks felt inescapable because the escort never lost contact. U-boat morale began to decline as casualties mounted. Admiral Karl Donitz, commander of the German submarine fleet, recognized the threat. He issued tactical directives attempting to counter the new weapon. Submarines were ordered to go deeper faster when escorts approached. They were instructed to make more radical evasive maneuvers. But these countermeasures had limited effectiveness against Hedgehog. The forward-firing capability meant escorts could track every evasive move. No matter which way the submarine turned, the sonar maintained contact. The only real defense was to avoid detection entirely. This forced U-boats to operate more cautiously and less aggressively. Their effectiveness against convoys declined as they spent more time hiding than hunting. The Battle of the Atlantic reached its crisis point in spring 1943. This period, known as Black May, saw the tide turn decisively against the U-boats. In May 1943 alone, 43 German submarines were sunk. This represented nearly 1/4 of the entire operational U-boat fleet. Hedgehog played a significant role in this dramatic reversal of fortunes. Combined with improved radar, better tactics and increased air cover, Hedgehog helped tip the balance. Convoy losses dropped sharply, while U-boat casualties skyrocketed. By summer 1943, Dönitz was forced to withdraw submarines from the North Atlantic. The wolf-pack tactics that had been so successful were no longer viable. The Allies had won the Battle of the Atlantic, and Hedgehog was a key factor in that victory. Individual Hedgehog successes demonstrated the weapon's effectiveness in dramatic fashion. HMS Lagan sank U-270 with a perfectly placed Hedgehog attack in August 1943. Multiple projectiles struck the submarine simultaneously, causing catastrophic damage. The submarine sank in seconds with no survivors. USS England, an American destroyer escort, achieved legendary status using Hedgehog. In May 1944, England sank 6 Japanese submarines in just 12 days. All 6 kills were made using Hedgehog attacks. This incredible feat has never been matched by any other anti-submarine vessel. England's success demonstrated what was possible with skilled crews and effective weapons. The ship's captain and crew had mastered Hedgehog tactics through practice and experience. They could conduct attacks with precision that made every attack potentially lethal. Admiral Ernest King, U.S. Chief of Naval Operations, specifically commended England's achievements. The ship became a symbol of American anti-submarine effectiveness in the Pacific. Hedgehog proved equally effective in both Atlantic and Pacific theaters. Japanese submarines faced the same deadly threat as German U-boats. The weapon's versatility made it valuable wherever submarines operated. Throughout the war, Hedgehog was credited with sinking or seriously damaging over 50 submarines. This represented a significant fraction of total submarine losses to surface escorts. Many other submarines survived Hedgehog attacks, but were forced to abort their missions. The damage inflicted often required submarines to return to base for repairs. This kept submarines out of action for weeks or months at a time. The indirect effects of Hedgehog were as important as the direct kills. Submarines that knew escorts had Hedgehog operated more cautiously. They stayed deeper, approached more carefully, and broke off attacks more readily. This caution reduced their effectiveness even when they weren't directly engaged. The mere presence of Hedgehog-equipped escorts influenced submarine behavior. Convoy protection improved dramatically once Hedgehog became widespread. Merchant ship losses dropped to sustainable levels by late 1943. The supply lines to Britain were secured, ensuring the island could continue fighting. This was essential for the build-up to D-Day and the liberation of Europe. Without Hedgehog and other anti-submarine improvements, the invasion might have been impossible. The technical evolution of Hedgehog continued throughout the war. Engineers developed improved versions with enhanced capabilities. The Mark X Hedgehog featured better aiming mechanisms and more reliable projectiles. Some variants used different projectile patterns, optimized for specific tactical situations. The basic concept remained unchanged, but refinements improved effectiveness. Training programs were established to teach crews proper Hedgehog employment. Specialized schools taught the coordination between sonar operators and weapons crews. Attack techniques were standardized based on combat experience. Crews practiced attacks against simulated targets until procedures became automatic. The best crews could conduct a Hedgehog attack in under 2 minutes from initial contact. This speed left submarines little time to react or escape. Maintenance procedures were developed to keep Hedgehog systems operational. The Spigot mortars were simple and required minimal upkeep. The projectiles were stable and could be stored for long periods. This reliability was crucial for ships on extended patrols far from bases. Unlike complex machinery, Hedgehog rarely broke down or malfunctioned. The American Navy embraced Hedgehog enthusiastically and produced their own version. American factories manufactured thousands of Hedgehog systems during the war. These equipped American, British, and other Allied escort vessels. The weapon became a symbol of Allied technological superiority. Germany attempted to develop similar weapons, but never achieved comparable success. Their forward-firing anti-submarine weapons remained experimental throughout the war. By the time they recognized the advantage Hedgehog provided, it was too late to catch up. The Allied lead in anti-submarine technology became insurmountable. The human stories behind Hedgehog operations reveal the weapon's impact at sea. Escort crews described the satisfaction of seeing Hedgehog projectiles strike home. After months of frustrating depth-charge attacks with uncertain results, Hedgehog provided clarity. Sailors knew immediately whether their attack succeeded or failed. This feedback improved morale and gave crews confidence in their weapons. Submarine survivors captured after Hedgehog attacks described the terror of the weapon. They reported hearing projectiles striking the hull like hammer blows. Sometimes multiple projectiles hit simultaneously, causing catastrophic flooding. The explosive power of Torpex made even a single hit potentially fatal. U-boat crews had no effective defense once a Hedgehog attack began. All they could do was pray the projectiles missed their vessel. This helplessness was psychologically devastating for submarine crews. The comparison between early war and late war anti-submarine effectiveness is striking. In 1940 and 41, U-boats sank ships at an alarming rate with relatively low risk. By 1944 and 45, submarines faced lethal danger every time they approached a convoy. Hedgehog was a major factor in this transformation. Combined with improved radar, better tactics, and increased air cover, it created a lethal environment for submarines. The average life expectancy of a U-boat dropped from years to months. New submarines and crews were often sunk on their first patrol. The German submarine service suffered 75% casualties during the war. This was the highest casualty rate of any military service in World War II. Hedgehog contributed significantly to inflicting these losses. The strategic impact of winning the Battle of the Atlantic cannot be overstated. Control of the Atlantic sea lanes was essential for Allied victory. American troops and supplies had to cross the Atlantic to reach Europe. British survival depended on imports that came by sea. Soviet forces needed Allied supplies delivered through Arctic convoys. If Germany had won the Battle of the Atlantic, the entire war would have been lost. Hedgehog was one of the key weapons that ensured Allied victory in this crucial campaign. After the war, Hedgehog continued in service with many navies worldwide. The weapon proved useful in the early Cold War period against Soviet submarines. Some navies used Hedgehog well into the 1960s. Eventually, more advanced weapons like homing torpedoes replaced forward-firing mortars. But Hedgehog's influence on anti-submarine warfare doctrine remained profound. The principle of maintaining contact during attacks became fundamental to ASW tactics. Modern weapons still embody this concept that Hedgehog pioneered. The development of Hedgehog also influenced post-war weapon design philosophy. Engineers recognized the value of weapons that provided immediate feedback. Contact detonation became standard for many types of anti-submarine weapons. The multiple projectile approach inspired later weapons like ASROC. Hedgehog demonstrated that innovation could come from unexpected directions. Sometimes the solution to complex problems was elegant simplicity. The Spigot mortar system was mechanically straightforward and reliable. It didn't require complex fire control computers or sophisticated aiming systems, yet it delivered results superior to more complicated weapons. This lesson influenced military procurement decisions for decades. The human ingenuity behind Hedgehog deserves recognition. Naval officers and civilian engineers collaborated to solve a critical problem. They identified the fundamental flaw in existing anti-submarine tactics. They designed an innovative solution that addressed the problem directly. They refined the weapon through testing and incorporated combat feedback. They produced and deployed the weapon at scale when it was most needed. This process demonstrated effective military innovation under wartime pressure. The scientists and engineers who developed Hedgehog rarely received public recognition. Their work was classified during the war and remained obscure afterward. Yet their contribution to Allied victory was immense. Thousands of merchant sailors owed their lives to Hedgehog's protection. The supplies that reached Britain and the Soviet Union helped sustain resistance. The troops and equipment that crossed the Atlantic enabled the liberation of Europe. All of this depended on winning the Battle of the Atlantic, and Hedgehog played a crucial role in that victory. The technical specifications of Hedgehog reveal its elegant design. Each projectile was 65 pounds total weight with 30 pounds of explosive. The projectiles were 7 inches in diameter and 30 inches long. They sank at approximately 23 feet per second. This sink rate was fast enough to reach submarines quickly, but slow enough for accurate placement. The elliptical pattern covered approximately 140 feet forward and 40 feet across. The 24 projectiles created a grid that was difficult for submarines to slip through. The spacing between projectiles was carefully calculated for optimal coverage. A submarine anywhere within the pattern had a high probability of being hit. The launcher itself weighed approximately 1 ton when empty. This was light enough to mount on corvettes and small destroyers. The forward mounting position required reinforcement of the forecastle structure, but the modifications were within the capability of most shipyards. Installation typically took only a few days for experienced crews. This ease of installation allowed rapid deployment across the escort fleet. The ammunition supply chain for Hedgehog was efficient and reliable. Projectiles were manufactured in large quantities by multiple factories. They were relatively simple to produce compared to depth charges. The contact fuses required precision manufacturing, but were not overly complex. Quality control ensured high reliability rates in combat. Duds were rare, and when projectiles hit submarines, they almost always exploded. Storage and handling of Hedgehog projectiles was safer than depth charges. The contact fuses were inert until armed by the firing shock. This meant projectiles could be stored and handled without risk of accidental detonation. Ships could carry large stocks of projectiles without safety concerns. The tactical flexibility of Hedgehog allowed its use in various scenarios. It was effective against submarines at periscope depth or running deep. The projectiles could be set to arm at different depths for specific situations. Against shallow-running submarines, shallower arming depths were used. Against deep submarines, the projectiles armed at greater depths. This adjustability made Hedgehog versatile across different tactical situations. Weather conditions affected Hedgehog accuracy, but less than depth charges. In rough seas, the forward firing capability maintained effectiveness. Depth charges had to be rolled off the stern, which was difficult in heavy weather. Hedgehog fired forward regardless of sea state. The mortar launch was relatively unaffected by ship motion. This all-weather capability was valuable in the North Atlantic's harsh conditions. Escort ships could prosecute attacks even in storms that would prevent depth charging. The psychological impact on escort crews was overwhelmingly positive. Sailors appreciated having a weapon that worked as advertised. The clear feedback from Hedgehog attacks boosted confidence and morale. Crews felt they had a genuine advantage over the submarines they hunted. This confidence translated into more aggressive and effective anti-submarine operations. Escorts no longer felt helpless against submarines. With Hedgehog, they had a weapon that could kill submarines consistently. This shift in attitude changed the dynamic of the Battle of the Atlantic. The legacy of Hedgehog extends beyond its immediate wartime impact. It demonstrated the importance of continuous innovation in military technology. Weapons that seemed adequate could become obsolete when tactics changed. New threats required new solutions rather than incremental improvements. Hedgehog showed that revolutionary changes could come from rethinking basic assumptions. The assumption that escorts had to pass over submarines to attack them was challenged. Once that assumption was questioned, the solution became obvious. Attack ahead of the ship to maintain contact throughout the engagement. This simple concept transformed anti-submarine warfare. Modern military forces still apply lessons learned from Hedgehog's development. Maintain sensor contact with targets during attacks. Provide immediate feedback on weapon effectiveness. Design weapons that can be operated by crews with moderate training. Prioritize reliability and simplicity over complexity. These principles remain relevant in 21st century warfare. The story of Hedgehog is ultimately about solving problems under pressure. The Allies faced an existential threat from submarine warfare. Existing weapons were inadequate, and something new was desperately needed. Engineers and naval officers worked together to develop an innovative solution. They tested, refined, and deployed Hedgehog in record time. The weapon proved effective immediately and continued improving throughout the war. It helped turn the tide of the Battle of the Atlantic at a critical moment. Thousands of merchant sailors and naval personnel owed their lives to Hedgehog. The supplies it protected helped sustain Britain and the Soviet Union. The troops it safeguarded went on to liberate Europe, In the grand narrative of World War II, Hedgehog might seem like a minor detail, but its impact on the war's outcome was profound and lasting. Without effective anti-submarine weapons, the Allies could not have won. Hedgehog was one of the key weapons that made Allied victory possible. The forward-firing anti-submarine mortar changed naval warfare forever. It proved that innovation and ingenuity could overcome seemingly insurmountable challenges. The engineers who designed it and the sailors who used it were true heroes. They faced the U-boat threat with courage and determination, and they prevailed through superior weapons and tactics. Today, over 80 years after its introduction, Hedgehog remains a fascinating case study. Military historians study its development and deployment. Engineering students learn from its elegant design principles. Naval officers understand its tactical innovations. The weapon embodies successful wartime innovation. It identified a critical need and filled it effectively. It was simple enough to mass-produce and deploy rapidly. It was effective enough to change the course of a major campaign. Few weapons in history can claim such impact. The Battle of the Atlantic was one of the most important campaigns of World War II. Control of the Atlantic sea lanes determined whether Britain could continue fighting. It determined whether American power could be brought to bear in Europe. It determined whether the Soviet Union would receive vital supplies. The outcome of the entire war hinged on this campaign, and Hedgehog played a crucial role in ensuring Allied victory. The weapon transformed anti-submarine warfare from a game of chance to a deadly science. It gave escorts the tools they needed to hunt submarines effectively. It changed the psychology of both hunters and hunted. Escorts became confident predators instead of desperate defenders. Submarines became hunted prey instead of invincible hunters. This psychological shift was as important as the physical lethality. The technical achievement represented by Hedgehog should not be underestimated. Creating a reliable contact fuse for underwater use was challenging. The fuse had to survive being fired from a mortar at high acceleration. It had to withstand impact with the water without triggering. It had to function reliably when striking a submarine hull underwater. These were demanding requirements that took skilled engineering to meet. The mortar system itself had to fire all projectiles with precise timing. The slightest variation in timing would ruin the pattern. The projectiles had to be aerodynamically stable in flight. They had to enter the water cleanly without tumbling or deflecting. Their sink rate had to be consistent and predictable. All of these technical challenges were successfully overcome. The result was a weapon system that worked reliably under combat conditions. The collaboration between British and American forces on Hedgehog was exemplary. The British developed the original concept and initial designs. American factories produced thousands of systems for both nations. Both navies shared combat experience and tactical improvements. This cooperation demonstrated the strength of the Allied partnership. Technology transfer between allies accelerated weapon development and deployment. Neither nation could have achieved the same results working alone. The Canadian Navy also made significant contributions to Hedgehog's success. Canadian escorts were heavily involved in Atlantic convoy protection. They achieved numerous submarine kills using Hedgehog throughout the war. Canadian shipyards installed Hedgehog on many escort vessels. The weapon became integral to the Royal Canadian Navy's anti-submarine operations. The evolution of submarine tactics in response to Hedgehog is fascinating. U-boat commanders tried various techniques to evade the weapon. Some attempted to crash dive immediately when escorts approached. But Hedgehog's forward-firing capability meant this often didn't help. The escort could track the diving submarine and attack while it descended. Other submarines tried zigzag patterns to throw off sonar tracking, but continuous sonar contact meant escorts could follow these maneuvers. Some U-boats released decoys or chemicals to confuse sonar. These tactics had mixed success and couldn't be relied upon. Ultimately, no reliable counter to Hedgehog was ever developed. The best defense remained avoiding detection entirely. This forced submarines to operate cautiously and reduced their effectiveness. The industrial production of Hedgehog demonstrated Allied manufacturing superiority. Thousands of launches and hundreds of thousands of projectiles were manufactured. This massive production sustained continuous combat operations. Escorts never ran short of ammunition despite heavy usage. The supply chain from factory to frontline functioned efficiently. This logistical success was as important as the weapon's technical capabilities. Germany could never match this level of industrial output. Their submarine force suffered from inadequate weapons and insufficient numbers. The material imbalance contributed significantly to their defeat. The training infrastructure built around Hedgehog was comprehensive. Schools taught both theoretical and practical aspects of the weapon. Instructors were often combat veterans who shared real-world experience. Students practiced on simulators before moving to live firing exercises. This thorough training ensured crews could operate Hedgehog effectively. The emphasis on coordination between sonar operators and weapons crews was critical. Successful attacks required seamless teamwork under pressure. Training programs fostered this coordination through realistic exercises. The maintenance and reliability of Hedgehog systems was excellent throughout the war. The simple mechanical design minimized breakdowns. Ships could maintain their Hedgehog systems with basic tools and training. Spare parts were readily available and easy to install. This reliability meant Hedgehog was always ready when needed. Contrast this with more complex weapons that frequently malfunctioned. Reliability is often more important than sophisticated features. Hedgehog proved this principle conclusively. The environmental considerations of Hedgehog were minimal. Unexploded projectiles that missed would sink to the ocean floor. The contact fuses would not detonate without striking something solid. This was safer than depth charges that exploded regardless of hitting targets. Marine life suffered less collateral damage from Hedgehog attacks. Of course, environmental concerns were not a priority during wartime. But the reduced explosive usage had unintended environmental benefits. The post-war analysis of Hedgehog's effectiveness confirmed its value. Statistical studies showed the dramatic improvement in submarine kill rates. Operations research analysts studied why Hedgehog worked so well. Their findings influenced post-war weapon development across all services. The importance of maintaining sensor contact became doctrine. The value of immediate feedback became recognized as essential. These lessons shaped Cold War anti-submarine warfare strategy. The Soviet Navy studied Hedgehog carefully after the war. They developed their own forward-firing anti-submarine weapons based on similar principles. The RBU series of rocket launchers owed much to Hedgehog's influence. This demonstrates how effective weapons inspire imitation and adaptation. The NATO navies continued using Hedgehog variants into the Cold War. Some ships retained Hedgehog even after newer weapons became available. Crews trusted the proven reliability of the system. Eventually, guided torpedoes and rockets replaced Hedgehog. But the transition took decades, as navies were reluctant to abandon a successful weapon. Some smaller navies used Hedgehog into the 1970s. This longevity speaks to the weapon's enduring effectiveness. The comparison between Hedgehog and modern anti-submarine weapons is instructive. Modern weapons have greater range and sophisticated guidance systems, but they're also more complex and expensive. Hedgehog achieved remarkable results with simple technology. This demonstrates that effectiveness doesn't always require complexity. Sometimes the right simple solution outperforms elaborate alternatives. The human factor in Hedgehog's success cannot be overstated. Skilled crews made the difference between success and failure. Training, experience, and teamwork were essential. The weapon provided the capability, but people delivered the results. This remains true in modern warfare despite technological advances. The best weapons are useless without skilled operators. Hedgehog demonstrated this fundamental truth. The integration of Hedgehog into existing ship systems was remarkably smooth. It worked with existing sonar without requiring major modifications. The fire control was simple and didn't need complex computers. Crews could be trained quickly without extensive technical backgrounds. This ease of integration accelerated deployment across the fleet. More complex weapons often faced integration challenges that delayed deployment. Hedgehog's simplicity was a key factor in its rapid adoption. The cost-effectiveness of Hedgehog was exceptional. Each launcher cost a fraction of what other weapon systems required. The projectiles were inexpensive to manufacture in large quantities. The return on investment in terms of submarines sunk was outstanding. Military planners recognized Hedgehog as a highly efficient weapon system. This influenced procurement decisions for other weapons. The emphasis shifted toward cost-effective solutions that delivered results. The tactical doctrine that evolved around Hedgehog was sophisticated. Escorts learned optimal approach angles for attacking submarines. They developed techniques for multiple attacks in rapid succession. Coordination between multiple escorts was refined. Some escorts would maintain sonar contact, while others attacked. This teamwork multiplied the effectiveness of individual ships. The doctrine emphasized aggressive prosecution of contacts. With Hedgehog, escorts could afford to be aggressive. The weapon's effectiveness justified taking risks to close with submarines. This aggressive posture put submarines on the defensive. The information warfare aspect of Hedgehog was interesting. German intelligence tried to understand why submarine losses increased. They knew escorts had new weapons, but details were scarce. Submarine survivors provided limited information about Hedgehog. Many attacks resulted in no survivors to report what happened. This intelligence gap left German commanders uncertain how to respond. They couldn't develop effective countermeasures without understanding the threat. Allied security around Hedgehog was excellent. Technical details were closely guarded throughout the war. This security prevented Germany from developing effective responses. The surprise advantage lasted until the war's end. The moral dimension of submarine warfare and Hedgehog's role is worth considering. Submarine warfare was brutal, with little chance of survival for victims. Torpedoed merchant ships sank quickly, giving crews little time to escape. Thousands of civilian sailors died in the Atlantic. Hedgehog helped protect these vulnerable merchant seamen. By sinking submarines, Hedgehog saved countless civilian lives. The weapon was defensive in nature, protecting convoys rather than attacking targets. This defensive mission was morally clear-cut. Escort crews knew they were saving lives with every submarine they sank. This moral clarity sustained morale during the grueling campaign. The technological legacy of Hedgehog extends to modern times. The principles it embodied continue influencing weapon design. Forward engagement to maintain sensor contact remains fundamental. Contact detonation for immediate feedback is still preferred where applicable. Pattern weapons that cover areas are still used against submarines. Modern torpedo and rocket systems owe conceptual debt to Hedgehog. The weapon proved that innovation could come from rethinking assumptions. This lesson inspired generations of weapons designers. The story of Hedgehog is ultimately a story of problem-solving. A critical military problem was identified and analyzed. The root cause of the problem was determined. An innovative solution was designed and tested. The solution was rapidly produced and deployed. Combat feedback was incorporated to improve effectiveness. The result was a weapon that changed the course of a major campaign. This process of innovation under pressure remains relevant today. Military forces still face unexpected challenges, requiring rapid solutions. Hedgehog provides a model for successful wartime innovation. The human cost of the Battle of the Atlantic was staggering. Over 30,000 Allied merchant sailors died. 3,000 Allied naval personnel were killed. 28,000 German submariners died, 3/4 of all who served. These casualties represent the brutal nature of submarine warfare. Hedgehog helped reduce Allied casualties by protecting convoys more effectively. Every submarine sunk by Hedgehog saved merchant sailors from future attacks. The weapon's contribution to saving lives was significant. This life-saving aspect is often overlooked in discussions of weapons, but defensive weapons that protect lives are as important as offensive weapons. The strategic implications of Hedgehog extended beyond the Atlantic. By securing the sea lanes, Hedgehog enabled Allied grand strategy. The buildup of forces in Britain for D-Day depended on safe Atlantic crossings. The supplies that sustained Soviet resistance came through protected convoys. The economic resources that funded the war effort required secure shipping. Without winning the Battle of the Atlantic, the Allies could not have won the war. Hedgehog was one of the key weapons that secured this vital victory. Its impact rippled through every aspect of Allied strategy. The final assessment of Hedgehog must acknowledge its revolutionary nature. It transformed anti-submarine warfare from reactive to proactive. It gave escorts the tools needed to hunt submarines effectively. It changed the psychology of the Battle of the Atlantic. The forward-firing anti-submarine mortar proved that simple innovation could have profound impact. Hedgehog stands as one of the most effective weapons of World War II. Its contribution to Allied victory was immense and lasting. The engineers who created it and the sailors who used it deserve recognition. They faced one of the greatest threats of the war and prevailed. This is the story of Hedgehog, the weapon that won the Battle of the Atlantic, the forward-firing mortar that changed naval warfare forever. A testament to innovation, courage, and determination. Forever remembered as the weapon that turned the tide. The Hedgehog anti-submarine mortar, legendary and lethal,